Good evening, everyone. Somebody from class had emailed me a couple hours ago and asked me how to do question 8 from today's assigned problems. So I'm just posting a video here for everybody. Question 8 tells you that you have a function, f of x equals x squared, and it's transformed into a new function. So in other words, f of x is an original function, and it's transformed into the new function g of x is equal to x minus h quantity squared plus k. And you're also told, and this is the pertinent information, you're told that this new function passes through 4, 8 and 7, 11. And the most important part of that is you understanding that that means when x is equal to 4, y is equal to 8. So if I put x equals 4 into the equation for the function g of x, I have to get for y 8. Similarly, if I put in x equals 7, I have to get y equals 11. In order for us to make a little bit of sense out of this, we're going to rewrite this g of x simply as y. So again, this equation, y equals x minus h quantity squared plus k, has to be an equation that makes both of these ordered pairs part of the graph. So what are we going to do with that information? Well, we're going to take this 4, 8, and we're going to feed it or load it into the function, and that's going to give us 8 equals 4 minus h quantity squared plus k. All I have done here is I've taken this and put it in for x, and I've taken this number and I've put it in for y. And this equation has to be true. 8 equals 4 minus h quantity squared plus k has to be true because the graph passes through 4, 8. And now what I can do is I can feed the 7, 11 in and get another equation. And again, all I've done is I've taken the x-coordinate of the point that's on the function and put it in for x, and I've taken the y-coordinate of that point and I've put it in for y. So what is it we do with these two equations? Well, you can't rearrange the first equation for h because you don't know k. I mean, I suppose you can rearrange the first equation for h, but you're not going to get a number because k is unknown. Similarly, you cannot solve the first equation for k because you don't know h. And everything that I've said about equation 1 is true about equation 2. But that leads us to the idea of a system of equations. These two equations have to both be true. So all I'm going to do is use algebra and a little bit of manipulation to find out what values of h and k make both of those equations true. In this particular case, I think it's easiest to take these two equations and subtract one from the other. And the reason why I'm going to subtract one from the other is because I notice that in one of the equations there's a k, and in the second equation there's a k. So if I subtract one equation from the other, I will not get any k's in the result, which is very nice because that means we're going to get an equation that has h in it, but not k, and we can solve that equation for h. Okay, so what do we get here? We take 11 minus 8, that gives us 3. Now I have to take the k minus the k, but k minus k is 0, so I'm not even going to write anything. And then finally we have to take the 7 minus h quantity squared and subtract the 4 minus h quantity squared, giving us, well, 7 minus h quantity squared minus 4 minus h quantity squared. Now, don't forget, you cannot afford to make junior high or grade 9 or grade 10 or even grade 11 mistakes here. 7 minus h quantity squared means you have to figure out what 7 minus h multiplied by 7 minus h is. So you can FOIL it out, but you're going to get 49. You'll also get a minus 7h, a minus 7h, and a plus h squared. So when I put them together, I have 3 on the left side equals 49 minus 14h plus h squared. And then we have minus, and what we did with the 7 minus h, we have to do with the 4 minus h. So we have to take 4 minus h times 4 minus h, And that gives us 16 minus 8h plus h squared, and we have to subtract that from 49 minus 14h plus h squared. And that blue set of brackets is another thing that you don't want to make a mistake on. Subtracting a polynomial means you have to subtract the entire polynomial. Forgetting that set of brackets is like a grade 9, 10 mistake. And unfortunately, if you do that, you're not going to get the grade 12 problem right. So let me get rid of, I think I need to get rid of this 7 minus h quantity squared. It's just in the way. What are we going to do with this equation? Well, we're going to solve it. I'm going to simplify things. So on the left-hand side of the equation, I have 3. On the right-hand side, what do I have? I have this 49 minus 16. 49 minus 16 gives us 33. I also have negative 14h minus negative 8h, and that's going to give us negative 6h. Then, of course, I have the h squared minus the h squared, which is 0. So this is the equation resulting from subtracting the two equations and simplifying. That's a piece of cake to solve. Subtract 3 from both sides to get 30 on the right-hand side and move your negative 6h to the other side. You're left with 6h equals 30. Divide both sides of that equation by 6, and you end up with h is equal to 5. So now we know one of the parameters. And, the question itself, I hope you read the question if you're following along. We're trying to find those two parameters. We're trying to find the value of h and k. So how do we find k now? Well, the answer is we take this h equals 5 and we put it into any of these equations that relate h and k. I think I'm choosing to put it into the second equation, the 11 equals 7 minus h quantity squared plus k. So all I'm doing is I'm putting this 5 in for h, because that's what h is equal to, and I'm left with 11 equals 7 minus 5 quantity squared plus k. 7 minus 5 is 2. So now I have 11 equals 2 squared plus k. 2 squared is 4, so I have 11 equals 4 plus k. Pretty simple at this point. You subtract 4 from both sides. So now you have your answers. The parameter h is 5 and the parameter k is 7, which means the original function f of x equals x squared was translated 5 units to the right and 7 units up. I hope that made sense. We'll see everybody tomorrow.